Hello, everyone. Thanks for clicking this link. This is a presentation for the 2021 National Cooperative Soil Survey Conference. My name is Stephen Hughes. I'm a professor in the Department of Geology at the University of Puerto Rico. On this presentation, my co-authors are Edwin and Desiree. They're grad students in the same department, and our friend and colleague Manuel Matos, who is the state soil scientist for Puerto Rico. And what we're looking at today is something called the Soil Mass Movement Risk Rating Index, comparing it to our Hurricane Maria landslide inventory that we developed after the storm hit us in 2017. Okay, so if we look at this landscape in the image here, we see one full of shallow mass wasting sites or landslide scars. This picture was taken just a few weeks after the hurricane passed through, and it's a great example of how the landscape responded to the atmospheric forcing in the hurricane. And so these types of mass wasting sites are important because they mobilize a lot of sediment, and that sediment is removed from the hill slope area. So any agricultural plots or activity on those hill slopes loses soil. The sediment then moves into our reservoirs, or it can move into our reservoirs, which is a big problem for us here. Or if it doesn't move into a reservoir, it can actually be taken to the ocean, and it can affect offshore biologic activity like coral reefs. And so I just want to say really quickly, everything I'm saying here is preliminary. This is an ongoing project. The information here doesn't reflect the opinion or the position of my university or the government. So where's Puerto Rico, just in case? We're out here between the Caribbean Sea and the Atlantic Ocean. The conference headquarters are out here, more or less, in Alabama. And similar to Alabama, in Puerto Rico, we often feel tropical cyclones during the season, and they affect us from time to time. Okay, and one of those times was in 2017. This is Hurricane Maria that passed over the entire island and affected us all. It was something that we will not forget, those of us that live in Puerto Rico, whenever this passed. So some of the landslides that other landslides that Hurricane Maria caused. This is one along a mountain highway. This is one that delivered sediment directly to a river. And then this is one in the El Yunque National Forest that mobilized a considerable amount of sediment off of the hill slope. So after the hurricane passed, we collected ourselves and we went to work. We first collected this inventory, or cataloged this inventory of over 70,000 mass wasting sites across the island. So at each little point you see here on the map is one landslide site. If we look at more of a heat map version of this, we can see where there were larger concentrations of landslides. The image that we saw on the first title slide was right around here, sort of in this bullseye in the center of the island, where there were more than 100 mass wasting sites per square kilometer. Okay, this is a published data set. We published it through the USGS. And the collection of this point inventory actually allowed us to develop another product, which is a high-resolution susceptibility map for all of the island of Puerto Rico. This is also published through the USGS. And what we looked at for all those 70,000 sites were the slope, the curvature, the soil type, the geologic type, the mean annual precipitation, the land use, lots of different site-specific factors. And we built a model, and then we applied that model across the island. And now we have this high-resolution landslide susceptibility map that exists from that. one of the most important factors that we used in that model was soil map unit. And so if we look here at this map of Puerto Rico, we have around 700 soil map units, and each one has a score or a susceptibility index that, for the purposes of this presentation, we'll just call low and high. And so we can see all the different units, and if they're high, they're red. If they're low, they're blue. And we compare this to an interpretation from the NRCS called the Soil Mass Movement Risk Rating. And it's an interpretation that uses soil characteristics from the soil survey catalog, and it combines them and yields a value that indicates if the soil is vulnerable or not vulnerable to mass movement. And if we look at the two maps, we have some discrepancy. We don't have an alignment of the empirical data set and then the soil mass movement risk rating on the bottom part. And we really think a lot of this is because we're in Puerto Rico, right? We're not in the continent. Our soils are different. They live in a different environment. We have different climate. Puerto Rico is removed from the continent, and a lot of things here about our ecosystem and our soil dynamics and our geologic history is different than the continent. But we wanted to look at this, compare these two things, and see what we can learn from this event and from our data that we've gathered from it. And so if we compare the two data sets, we look here at the big map on the bottom now. If the soil map unit is green, that means that the soil mass movement risk rating is underestimating. So there's sort of a larger collection of darker green here in the center that sort of corresponds to this group of soil units. And then if it's red in this bottom map, mostly this belt of soil units up here, we see that the soil mass movement risk rating has overestimated the vulnerability or the susceptibility to mass wasting. And if it's white on the map, then we're sort of in a plus or minus 10% match. So white in this map means that there's a good match. And so we organized this project with our friends at the Caribbean area office, and we want to do two primary things. We want to do a statistical analysis using something called principal component analysis of different soil unit characteristics to see if we can isolate those soils that we noticed were so vulnerable versus those that were not vulnerable. And then we also, point number 2, want to characterize how much volume are we losing in specific soil units. So really quickly here, in the principal component analysis to accomplish goal 1, we've seen that characteristics like sand, silt, and clay percent really are the ones that distinguish the soil units the most. I can't really explain what is principal component analysis right now, but it's a way to use multivariate data and look at it through combinations of those different variables. So on this map, we have different colored dots. The red dots are soil map units that are more vulnerable, and the blue dots are ones that are less vulnerable. And so what we see with our analysis is that really there's no grouping or segregation through principal component analysis of these red dots, which are the soil units that suffered the most during the landslide activity. And really, we don't think that we're gonna see that that type of segregation of the data that we hypothesized that we would. And so we've looked at it a few different ways, different depths, different combinations of factors, but it ends up that we don't see that grouping of especially vulnerable soil map units. We do see that there's about 50% of the variance from principal components 1, 2, and 3. And then, so one thing we're looking at now is plotting this in 3 dimensions to see if we see any 3D grouping rather than any 2-dimensional grouping. And really, this is just sort of our first attempt at this, and we don't have any concrete final conclusions about that yet. Our second objective that we've done, or that we've taken on, is to look at the volume. And so we have LIDAR data sets that are really helpful for this. We have a pre-Hurricane Maria LIDAR data set just by chance. That was in 2016. And then we have a post-Hurricane Maria LIDAR data set in 2018. So we have really good control, time control, and really good resolution digital elevation data. So what we can do, if you look closer here at this image, we can identify from our inventory of points and polygons different landslide sites, and then we can do Lidar differencing. We can look at, for example, the 2016 Lidar model that you see here. We can compare it to the 2018, and we can do a difference. We can essentially subtract and see where our elevation difference is. And so within this feature here, this landslide that was highlighted in blue, we see a zone of loss right here in the headscarp, which is what you expect. We can clean up the data a little bit, get rid of some of the noise in the data, and then we can isolate just that zone of loss within the landslide, and we can get an estimate of the volume of material lost. And so in this case, what I have here is about 1,500 cubic meters of material, and depending on the density of that material, if it's more rock or more soil, somewhere around 3,000 tons of material at this one site. And so what the goal is that we can do this on thousands of sites for different soil units that were very much affected by landslides, and then we can get some scaling parameters where we can have the estimate of volume based on the area of the actual landslide site. So yeah, I think I'll end it there. I didn't keep it to 10 minutes, but 10 minutes is really short, right? So I just want to show again an image. This is from a person's farm out in the mountains of Utuado. This is after the hurricane, and you just see that the farm is completely wrecked by landslides. All right, and it's our goal to learn as much as we can from these catastrophic events, and don't lose the opportunity to understand the dynamics of how our atmosphere and our lithosphere are interacting, and how one can force the other. So yeah, that's it. Thank you. I'm not a big fan of recorded lectures. I wish that I could talk to everyone right now in person, or at least in real time. But if you want to get in touch with me or Manuel, there's our email addresses right there. Or you can check out our Facebook page for the program that I direct here in the Department of Geology at University of Puerto Rico. It's called Slides PR, facebook.com/slidespr. Okay, thank you all. I really appreciate it. And yeah, thank you.